that's a tough one there. I don't know. We know it, the hyperbolic cosine is that, right?
Oh, where's
Well, wait, this is, that's not equal. This is the hyperbolic cosine of x, right? So I believe what we want to do is set 2 equal to that. That sound right? And try to solve that. Yeah, I think we're going to have to involve some technology here. So if we multiply to get to there, yeah, I think that's the only way we're going to be able to do this. So you can make it equal to 0 and then, graph this on your calculator and find the 0. I guess will be about our only way out of that one. Okay. Anything else?
So there's circular signs and hyperbolic signs. Are there parabolic signs?
Not that I'm aware of. I wouldn't say, and I'm not going to jump and say, no, I've not heard of anything like that.
All right.
Yeah. Fair question. I don't know if there's any other kinds of signs other than the ones you have now seen.
All right.
And these are really, we don't really have anything to do with trig. Kind of interesting. Okay. Anything else?
Can we do number 11?
11. Can you tell me what that is?
It's sine 8 to 3x equals 3 sine 8 of x plus 4 sine 8 of x.
So that's hyperbolic sine, or you can call it sinh. So 3 hyperbolic sine of x. What was the last part of that?
Plus 4 sine 8 cubed. Hyperbolic sine cubed of x.
Are these right?
Yes.
So I think what we want to do, I think we want to try to, since these have different arguments, they have different things that are inside of them, I think we want to try to make this be something where it agrees with the others. So I think there is some identities on that, on there perhaps. I want to see if I can find where that is. So do you have a copy of your worksheet there? I don't know if I do either.
Where would it be?
So in the
Yes.
first page or two, let's look over Macy's shoulder there. And let's see. No, that one there. Let's try the. So do you have that? Can you see that at all, or do you need me to write that down?
See what?
Can you see what?
Up at the top of the Larson worksheet that you got the problems from.
Oh, I was looking at Canvas. I don't have a list.
Okay, well, can you read that first to us? The hyperbolic sine of x plus y, what that says, Macy?
Hyperbolic sine x, hyperbolic cosine x, y, plus hyperbolic cosine x, hyperbolic sine y. So sinh x cosh y plus cosh x sinh y.
Cosinh. Right, sinh. Okay, so I think what we want to do is treat this 3x first, and I could be wrong here, but let's think of that as the y as being 2x. And then we also have a double angle formula that we're going to use for that one. So I think this would become sinh x cosh 2x plus cosh x sinh 2x. Now, Macy, can you tell us what the identity is for sinh 2x?
2 sinh x cosh x.
And how about for cosh 2x?
Cosh squared x plus sinh squared x.
Sinh squared x. Okay, I don't know. I hope this is working because we're going down the rabbit hole otherwise. Okay, so far. So let's see. That's going to become, I believe, sinh x, the cosh 2x, we're going to call cosh squared x. I don't like that cosh squared in there. I was hoping we get all cinches. to there plus cosh x times 2 sinh x cosh x. Wow. Okay, so far. No, but all right. So we have a sinh x, a cosh squared x, a sinh cubed x, a 2 sinh x cosh x, and that was a plus. No. Cosh. Where did I come from? Oh, I was there. Oh, that's right. So no, this is just all, that's 2 sinh cosh squared. Does that look right? Okay, so one of those and two of those makes 3 sinh x cosh squared x, and then we got a sinh cubed x. Yeah, all that was our sinh 3x, right? So we started with that, and we got to this. So we're going to hopefully say that's equal to 3 sinh x. I don't know if this is going to work or not, guys. Maybe, squared.
Is there an identity for cosh squared?
We do actually, because we know cosh squared minus sinh squared is 1, isn't that correct? So cosh squared x is sinh squared x plus 1, true? So, oops. So, if we say that's 3 sinh x times sinh squared x plus 1 plus sinh cubed x. We're there. Look at that. 3 sinh cubed x plus 3 sinh x plus 1 more sinh cubed x is indeed equal to that. Ta-da. Thank you. You're too kind. Okay. Anything else? Okay, so what I want to talk about, I want to start talking about today, and I want to continue talking about tomorrow, is integration by tables, which is you have before you, and there is on Canvas, and for those watching virtually, I have a hard copy if you want, this list of tables. So what happens in real life, so I'm told, I don't really participate in that, but what I'm told is that you study all these integrals, and you have become very good at finding integrals, and you have all these different techniques of integration. So you know a bunch of integrals like the trigs and the inverse trig integrals, and you know about e to the x and natural log x and all those things. And you can do integration by substitution, and you can do integration by parts and partial fractions. And you can do now trig substitution. And on the last test you did, you showed that you were actually pretty darn good at doing integrals. But you've been spending a lot of time doing that lately. What happens sometimes is when you start working in some field, you may not actually do integrals on a daily basis. And so then in the course of whatever you're doing, you may encounter an integral. And you may be like, oh man, I know at one time I knew how to do that integral. I don't remember. And so there are available these tables of integrals. And so it's a way of kind of finding a formula for how to do an integral, how to get an antiderivative of some function. And it sounds like this will be really easy, simple, and straightforward, but I think as you'll find in the next couple days, it's much more layered than that. It is not always easy to find, first of all, the integral you're trying to evaluate, which one is it? And sometimes it won't fit one, and then there's some other options that we'll talk about that you can do there. So what first I want you to do is kind of just go through and notice they are broken into categories. So there are several categories of functions there. So in particular, you will see there's one that's u to the n, and then the next class is those that fit the form a plus bu, and then there's another one, a plus bu plus cu squared, and then another one that's the square root of a plus bu, 1, 2, 3, 4, a fifth one that's a squared plus or minus u squared, one that's a square root of a squared plus or minus u squared plus or minus a squared. Of course, those are all could have been done using trig substitution, as could the next one, the square root of a squared plus u squared. Then you'll see trig functions, followed by inverse trig functions, exponential functions, and logarithm functions. So when what we are going to do here is I'm going to force you to use this table to do the integral, even if you know how to do it without using the table,
Oh, don't worry,
which
I
you
don't
do.
remember anything.
which you do. But then the first thing that you're going to have to do in showing your work is tell me which formula you think is the correct one. So you're going to tell me like the number that you are going to use. You see all those numbers there all the way up to 91. So you're going to pick some number between 1 and 91. Then you're going to tell me, what are you going to call A? What are you going to call U? What is the du? And see that you can't change the integral that you actually have into the form that's going to be used in the table, and then get the result that's going to be there. And so it can be a little tricky. Katya, question?
Oh, I was just gonna ask you answer my question, if we could just like write down the number.
Yeah, I just want the number.
Go straight to it.
But then you still got to tell me, what are you going to call u? So u might be as simple as x, but not always. I mean, u might be 3x, it might be x squared, it might be e to the x, it might be sine of x. It might, I mean, there are different things that you might have to do in order to make it be doable.
We just
Okay.
have to define the variables up top, like
Yes.
the function included.
And then when you pick a u, you're going to need to know what the du is as well. So let's do an example and see kind of how this works. So we are going to start with the integral of dx over x times the square root of x minus 1. So first what I want you to do is see if you can determine so find the number that's going to give us the correct formula to try to follow. And then once we have agreed on that number, then we'll talk about what is the a, the u, and the du, and so on. It's kind of tricky, huh? Think you have it?
33.
17.
It's actually 17. So can you find 17 and see how it fits that form? Okay, are we all okay with that? So then on 17, you need to say what is the A, what is the U, what is the B, and what is the du. So the A is going to be what?
Negative outside.
Yeah, negative, good. And what's the B going to be? Good. And what's the U going to be? And that means the du is going to be dx. So on a test question, all of this stuff must be shown. Okay. And then from here, I think it's pretty straightforward, maybe not. can you come up with what the antiderivative is? What is the indefinite integral going to be? Anybody want to take a shot at that? So we are, yeah, so are we going to top branch or the bottom branch? Bottom branch. Okay, see how that, depending what A is, if it's positive or negative. Okay, I need nods of heads. Yes, we see. Okay. And so on the bottom branch then, what will that look like? 2 arctangent of negative 1 plus x or x minus 1. Is that okay? And then you plus c. Does that make sense? You see, I think already you can see this is not really a walk in the park. I think some of these get really tricky to, we'll talk about those. So let's see, let's try another one. Let's do the integral of x times the square root of x to the 4th minus 9 dx. So remember, first, you're going to have to try to figure out which one is it. And keep in mind, if you make a u substitution, there has to be a place for du in that integral. So you got to account for that. I don't think that's the right one. So Lord, I want to say, which one? Remember, you got that x to the 4th. So I got a feeling you may be saying u is x squared. In which case du is going to give you an extra power of x. That's going to be that x outside the radical. Kati, do you have an idea? Which one?
Is it just 37?
I don't think it's 37.
We're not very good at this game.
No, it's not easy. That's what I'm trying to tell you. You're finding out exactly what I wanted you to find out. Sorry, which one? I don't think quite 27, but you're really close. It is indeed 26. It's not 26? Yeah, and the order matters. Yeah. Okay, well, we are going to spend another day on this. So if you want to try to start on the homework or maybe watch the video or something, but we'll work on this more tomorrow as well.